Welcome back to Science and Slumber, the quiet corner of the cosmos, where we explore the universe's greatest wonders, not with speed, but with stillness. Tonight, we're going on a slow, soothing journey to the furthest imaginable place. We are going to travel together, in our minds, until we find the answer to a very simple question: where does space end? It sounds simple, almost like a child's question, but the deeper you fall into it, the more the question itself begins to unravel. It transforms from a query about a place into a quiet meditation on the very nature of everything we see and everything we don't. I hope this story helps you drift off into a deep and peaceful rest, or perhaps it keeps you pleasantly curious, hovering in that gentle, weightless state just before sleep. If you find a moment of stillness, and you can, a quiet tap on the like button and maybe a soft click on subscribe, it truly and quietly helps this sleepy little channel grow. I often wonder where you are listening from tonight. Are you in a quiet apartment in New York, with the city's hum fading to a distant whisper around 11:30 p.m.? Or are you perhaps in the early silent hours of a London morning, with the first hints of dawn still a long way off? Wherever you are, I hope you feel connected in this shared moment of calm. So settle in, get comfortable. There is nothing you need to do, nothing to remember. Let the words wash over you like the cosmic background radiation, a gentle, steady glow from a time long past, filling every corner of your room. Ready? Let's begin. To begin our journey, let us first think about the word end. On a human scale, on our gentle, quiet earth, an end is a familiar thing. It is the wall of a room, cool and solid against your fingertips. It is the shoreline where the land gives way to the sea, the rhythmic whisper of water meeting sand. It is the edge of a forest, where open meadows suddenly rise into a thicket of ancient trees. Our lives are defined by these gentle boundaries, these places where one thing becomes another. And so, naturally, when we look up at the vast dark canvas of the night sky, our minds project this same simple idea outward. We imagine traveling in a straight line, on, past distant galaxies that glitter like scattered salt, and we assume that eventually we must arrive at something, a final cosmic wall, the very last place. Let's explore that feeling together. Imagine, if you will, that you are standing in a room, but this is no ordinary room. It is impossibly vast, and it is perfectly peacefully dark. There is no echo, there is no draft. The air is still and silent, and the floor beneath your feet is smooth and seamless, stretching away into an unseen infinity. You are here to find the edge. You take a step, and then another. The sound of your own quiet breathing is your only companion in the stillness. You walk for what feels like minutes, then hours, your hand outstretched, waiting to feel the familiar, solid presence of a wall. You are expecting it. Your mind has built a picture of it. Perhaps it is made of dark, cosmic stone or a shimmering, crystalline substance. You anticipate the gentle thud of your fingers making contact, the definitive proof that you have reached the end. But it never comes. You continue on, and the darkness remains utterly consistent, the silence unbroken. The air does not change, the floor never ends. After a time, the anticipation begins to fade, replaced by a deep and profound curiosity. Your walk is no longer a search for a barrier, but a meditation on the space itself. The goal is no longer to arrive, but simply to move through this endless, quiet expanse. You begin to realize that the room isn't a container in the way you once thought. The room is simply the way things are. It is the space that allows for your journey, and it has no need for a beginning or an end. What this really means is that our first and most intuitive idea about the end of space is based on our experience of objects, of containers. But space isn't an object. It is the quiet, invisible stage upon which all objects exist. There's something quietly poetic about this idea, the realization that we were searching for a feature, when in fact we were swimming in the answer all along. The universe doesn't seem to be built like one of our rooms. It doesn't appear to have an edge you could stub your toe on, a final frontier made of matter. The human mind, shaped by coastlines and garden fences, instinctively looks for this, but the cosmos is under no obligation to be so simple, so familiar. It operates on a scale our intuition can barely grasp, with rules that are far more elegant and strange than the simple architecture of our homes. The idea of a physical wall, something to press a hand against, simply dissolves into the quiet darkness. However, the boundary of our universe isn't where we might place it. The first true edge we encounter is made of something much gentler and much older than stone. That gentler, older boundary is not a wall in space, but a horizon in time. To feel what this means, let us leave our dark, infinite room and find ourselves somewhere else. Imagine we are now on the deck of a small, quiet ship, floating on a perfectly calm and endless ocean. It is a moonless night, and the water is as black and smooth as polished obsidian. Above, the sky is a velvet dome, filled with the soft, shimmering light of a billion unfamiliar stars. There is a profound sense of peace here. The only sound is the gentle, rhythmic lapping of the water against the wooden hull, a soft, percussive heartbeat in the immense silence. You can feel the cool, clean air on your skin, carrying the faint, clean scent of salt and distance. You feel safe and small in the most wonderful way. From the deck of our ship, we can see in every direction. The world appears as a perfect circle of starlight and dark water. But our view is not infinite. At the very edge of our sight, in a soft, uniform ring all around us, is a thick and luminous bank of fog. It is not a hard wall that our ship could crash into. It is a gentle, opaque curtain that we simply cannot see beyond. We know instinctively that the ocean continues past that fog. There are other waves, other stars, other deep and silent currents flowing out there in the darkness. But from our vantage point, on our little ship, the world ends in that soft, impenetrable haze. We are floating in the center of our own visible world, a bubble of clarity in a potentially infinite sea. This is our universe. We are on a small ship called Earth, floating in a vast cosmic ocean, and the foggy bank on our horizon is the observable universe. It is the most distant edge of everything we can see. This horizon exists for a very simple reason. Our universe had a beginning. It is about 13.8 billion years old. And light, the fastest thing there is, travels at a finite speed. This means we can only see the stars and galaxies whose light has had enough time in those 13.8 billion years to complete the long journey across the ocean of space and finally reach our ship. The light from anything beyond that horizon is still traveling, still on its way, but it hasn't reached us yet. In other words, the edge we can see is not the true edge of existence. It is simply the edge of our own past. There is a quiet beauty to this realization. When we look out with our most powerful telescopes to the faintest, most distant smudges of light, we are not just looking out in space, we are looking back in time. That fog bank on the horizon is not a place, it is a time. The earliest time we can possibly see, just after the universe was born. What this really means is that our view of the cosmos is a sphere with us at the very center, not because we are special, but because we are the ones who are looking. Every observer on every distant, glittering galaxy would find themselves on their own ship, at the center of their own observable circle. The universe doesn't have one center. It has countless centers, one for every point of view. But there's a quieter detail we've skipped, a subtle motion in this grand cosmic scene. The very canvas upon which the stars and that distant fog are painted is not a fixed and silent thing. That cosmic canvas is not still. The great dark ocean we are floating on is not a placid, silent body. It is subtly, powerfully, and universally in motion. But the motion is not what we might expect. The distant galaxies are not like other ships, sailing away from us under their own power. Instead, the very water of the ocean, the fabric of space itself, is swelling. It is a slow, majestic, and ongoing expansion, carrying everything along with it, like gentle, silent currents pulling every island, every ship, every speck of dust further and further apart. To understand this, we need a new picture in our minds. Let us set aside the ocean for a moment and hold in our hands a small, uninflated balloon. Imagine it is the color of the deepest night sky, a dark, velvety indigo. On its surface, we have drawn 1,000 tiny silver dots, each one representing a galaxy. Now, with a slow and steady breath, we begin to inflate the balloon. Watch what happens to the silver dots. From the perspective of any single dot, all the other dots are moving away. The nearby dots are moving away slowly, while the dots on the far side of the balloon are rushing away much faster. But here is the crucial, beautiful detail. None of the dots are actually moving asterisk across asterisk the balloon's surface. They are not crawling over the rubber. It is the rubber itself, the two-dimensional surface of the balloon, that is stretching. The space between the dots is what is growing. There is no center to this expansion asterisk on the surface of the balloon asterisk. Every single dot could claim to be the stationary center from which all others are receding, and if the dots were conscious, they wouldn't feel the balloon itself, only the growing distance to their neighbors. This was the profound discovery made in the quiet, cold observatories of the 1920s. A man named Edwin Hubble, spending long, patient nights looking at the faint smudges of distant galaxies, noticed something extraordinary. The light from these galaxies was stretched, its waves elongated, a phenomenon called redshift. It was like the sound of a distant siren, its pitch dropping lower as it moves away from you. Hubble found that the further away a galaxy was, the more its light was stretched and the faster it appeared to be receding. The conclusion was inescapable, and it shook the very foundations of our understanding of the cosmos. The universe was getting bigger. In other words, the galaxies are not running away from us through a static, pre-existing void. The void itself, the very stage of existence, is expanding, and the galaxies are simply being carried along for the ride. What this really means is that our search for an end is like trying to find the edge of that balloon's surface while it is still being inflated. Not only is there no edge to be found, but the very distances we are trying to cross are increasing with every passing moment. The fog bank on our cosmic horizon is not a stationary feature. As we watch it, it is also receding from us, carried away by the same cosmic tide. There's something quietly humbling about this idea. The universe is not a fixed map. It is a living, breathing, growing thing. It is an event that is still unfolding. Our journey to its edge is a journey through a landscape that is constantly and silently transforming all around us. We are not explorers in a finished museum, but participants in a creation that is still taking shape. The light that travels this stretching path is changed by its journey, and this change creates a boundary that is less like a fog and more like a wall of time. Let's think about that patient traveler, a single photon of light on its journey across this stretching, growing canvas. It is born in the heart of a star that lived and died billions of years before our own sun ever ignited. For eons, it travels through the expanding quiet, a silent messenger from a world we can never know. As it travels, the very space it moves through stretches beneath it, like a river current pulling it along. This stretching has a profound effect. The photon's energy, its very wavelength of light, is stretched out along with space. A vibrant, energetic blue light, over billions of years, will be gently, slowly coaxed into a soft, tired red. If it travels for long enough, it will be stretched beyond red, into the invisible realms of infrared, and then microwaves, and then radio waves, its message fading into a long, slow whisper. To feel this, imagine you are standing in the heart of a vast, ancient forest just before sunrise. The air is cool and still, thick with the scent of damp earth and pine. A thick, silvery mist hangs between the colossal trunks of the trees, and the world is painted in shades of charcoal and deep indigo. There is a deep, profound silence here, the kind of quiet that feels ancient and alive. You are waiting for the dawn, and then it begins. A single golden ray of light breaks over a distant ridge. It touches the very tops of the highest leaves, and then it begins its journey down into the forest, toward you. At first you can only see the trees immediately around you, their dark bark slowly illuminated by the growing light. As the seconds tick by, the light pushes deeper into the mist, and more trees are revealed, their shapes emerging from the gloom. Then more, and more still, your world, your visible forest, is expanding with the speed of light. The edge of your world at any given moment is not a wall of trees. It is simply the furthest point that the dawn's light has had time to reach. The forest beyond that edge is real. It is there, but it remains in darkness, waiting for the light to arrive. That moving boundary is a wall, made not of substance but of time. This is our view of the cosmos. The Big Bang was the great dawn of our universe. The light from that first brilliant fire has been traveling through the cosmic forest ever since. The edge of what we can see, our cosmic horizon, is the front line of that ancient light. When we look at the most distant galaxies, we are seeing them as they were when they were young, their light just beginning its long journey. We see a younger universe, a smaller universe, a forest still thick with the mist of creation. And if we could look all the way to the horizon, we would see the dawn itself, a time when the universe was so hot and dense, it was an opaque, glowing fog. This is the cosmic microwave background. It is not a wall asterisk in asterisk space. but the wall asterisk of asterisk time. There's something deeply humbling in this thought. A quiet Belgian priest and astronomer named Georges Lemaitre was one of the first to truly grasp this. In the 1920s, with just mathematics and a profound intuition, he imagined the universe's history rewound, tracing the expansion back to a single primeval atom, a day without a yesterday. He saw the dawn in his mind long before we ever saw its faint, lingering glow with our telescopes. What this really means is that our journey has brought us to a new understanding. We started by looking for a place, a physical edge, but the universe has shown us that the only true boundary is time, and this realization forces us to change our question, to shift our perspective from where to what. So our journey outward, to the very edge of sight, has turned us inward. We have reached a boundary made of time, a glowing wall of the past that we cannot see beyond. And this realization does something remarkable. It gently takes our original question, where does space end, and it reframes it. The question was a good one. It got us here. But it was a question about a destination, a location, a final point on a map. The universe, however, seems to be hinting that this is the wrong kind of question to ask. The search is not for a place, but for a property. The real question is not asterisk where asterisk it ends, but asterisk what asterisk it is. To understand this shift, imagine a tiny, patient creature, an ant, living in a world of one dimension. Its entire universe is a single straight line, drawn in graphite on a vast white page. The ant knows only forward and backward. Its life's great philosophical quest is to find the end of its universe. It sets out walking and walking and walking, believing that eventually it will come to the point where the graphite stops, the final edge of its reality. For us, looking down from our higher dimension, we can see the line stretches for miles, but we know it must end somewhere. The ant's quest, from our perspective, seems reasonable. Now let's gently lift the ant and place it in a new universe. We place it on the smooth, polished surface of a simple golden ring. For the ant, this world still feels like a line. It can only move forward and backward along the curve. It has no concept of up or down or across, and so it begins its quest again, walking forward to find the end. It walks and walks past landmarks it doesn't yet recognize. It continues on, its tiny legs carrying it around the gentle curve, feeling only the smooth, unending path beneath it. It never encounters a boundary. It never finds an edge to fall off. But after a long, long time, it sees something familiar up ahead. It is the very place it started. At this moment, the ant has a profound revelation. Its world has no end. Not because it is infinite, but because it is curved. It is finite. You could measure its circumference, but it is unbounded. You can walk on it forever. The ant realizes its mistake was never in the journey, but in its assumption about the shape of its world. It stops asking, where is the end of the line, and begins to ask, what is the nature of this loop? It has shifted its question from asterisk, where asterisk, to asterisk, what asterisk? We are that ant. For centuries, we have been walking in what we assumed was a straight line through our three-dimensional space, looking for the end. But the clues, the expanding canvas, the horizon of time, are suggesting that our universe might be like that golden ring. Our three dimensions of space might be gently, imperceptibly curved in some unseen higher fourth dimension. What this really means is that our entire cosmos could be finite, holding a limited volume, and yet have no edge, no center, and no outside. It could be a place you could travel through in a straight line forever, only to eventually, after an almost unimaginable amount of time, arrive back exactly where you began. This shift allows for the most profound possibility of all, a universe that is finite in size, but utterly without an edge. And the next clue is a shape that is both simple. The question has now transformed. We are no longer searching for a wall, but for a shape. And this leads us to the quiet, central, and most mind-altering idea of our entire journey tonight. The universe can be finite. It can contain a limited amount of space, and yet have no boundary at all. It can be a place with no end, and no outside. This sounds like a riddle, a paradox that our minds, so used to boxes and rooms, struggle to hold. But it can be understood and felt through a simple, elegant, and powerful analogy. Imagine a perfect sphere, like a smooth marble globe resting in a dark, quiet room. It is a familiar, comforting shape, but we are not going to look asterisk at asterisk it. We are going to imagine living asterisk on asterisk it. Picture yourself as a perfectly flat, two-dimensional being. Your entire existence takes place on the surface of this vast, polished globe. The surface is your universe. As you stand there, what do you see? In every direction, your world looks perfectly flat. The curve of the sphere is so immense, so gentle, that from your perspective on the ground, the surface stretches out to a perfectly circular horizon, just as it does on our Earth. There are no walls, there are no cliffs, there is no edge to fall from. It is an open, seamless landscape. You decide to embark on the ultimate journey, to find the end of your world. You pick a direction, and you begin to walk, convinced you are moving in a perfectly straight line, and you are. On the surface, your path never deviates. You cross continents of smooth marble, oceans of polished stone. Days turn into weeks, weeks into years. You are on a grand pilgrimage to the boundary of reality. The scenery changes, but the fundamental nature of your world does not. The ground is always flat beneath your feet. The horizon is always a circle. There is never, ever a wall. And then, after a journey so long you have almost forgotten where you started, you see a familiar landmark on the horizon ahead. It is your own home. You have circumnavigated your entire universe and arrived back where you began, without ever turning around and without ever hitting a dead end. In that moment, you understand. Your world is finite. You could, in theory, measure its total surface area, but it is also unbounded. It has no edge. It is a self-contained, closed and complete system. There is no outside for you to get to. The very concept of outside is meaningless in your two-dimensional existence. This was the kind of thinking that the brilliant 19th century mathematician Bernhard Riemann explored, sitting quietly with just paper and his imagination. He conceived of geometries that our eyes cannot see, worlds that curve in ways our senses cannot directly feel, pioneering the very mathematics Einstein would later use to describe gravity and the shape of the cosmos. What this really means is that our own three-dimensional space could behave in the exact same way. Just as the two-dimensional surface of the sphere curves through a third dimension to close back on itself, our three-dimensional universe could be gently curving through an unseen fourth spatial dimension. The cosmos could be a higher dimensional version of that sphere, a shape called a hypersphere. It would be a universe that is finite in volume, but without any boundary. A universe where you could fly your spaceship in a straight line, past billions of galaxies for trillions of years, only to eventually find the soft, familiar light of your own home star, the sun, appearing in your cockpit window once more. The surface of a sphere is a gentle, two-dimensional picture, but our universe has depth. So let's imagine, together, what it might truly feel like to live inside this shape's grander, three-dimensional cousin. To truly feel what it might be like to live inside such a cosmos, we must let our imaginations drift into a place our eyes can never see. Let us try to picture this hypersphere, not as an object we are looking at from the outside, but as the very space we are floating within. Imagine we are back on our quiet ship, but this time, it is not on an ocean, but adrift in the deep, silent black of interstellar space. The ship is our home, a tiny bubble of warmth and gentle light, surrounded by the velvet darkness and the distant diamond dust light of a billion galaxies. From our window, space looks just as we expect it to. It is vast, empty and straight. The light from a distant star travels towards us in what appears to be a perfectly direct line. But in this universe, in this great cosmic hypersphere, there is a subtle, imperceptible curvature to everything. The very fabric of space is gently, slowly, folding back on itself through a fourth dimension that we cannot point to. Just as a two-dimensional being on the sphere cannot point up into our third dimension. It is a direction that is not forward, backward, left, right, up or down. It is a direction our senses are not built to perceive, yet it defines the ultimate shape of our reality. The effect is impossibly subtle, noticeable only over truly cosmic distances. It's like standing on a calm sea and not noticing the curvature of the earth. The world feels flat, but its true nature is round. Imagine we send out two powerful beams of light from the front of our ship. We aim them so they are perfectly parallel, two straight lines of pure white light, setting off on a journey into the infinite. In a flat universe, they would travel alongside each other forever, always maintaining the exact same distance between them. But in our gently curved hypersphere universe, something quiet and strange happens. Over billions of years, as these two beams cross the vast empty gulfs between galaxies, the subtle curvature of space-time begins to act on them. Ever so slowly, almost immeasurably, the two parallel lines begin to converge. They are like two travelers who set off walking due to north from two different points on the Earth's equator. They both believe they are walking in straight parallel lines, yet they will inevitably meet at the North Pole. So it is with our beams of light. After an almost eternal journey, spanning perhaps 100 billion light-years, those two parallel lines would finally meet, and if they continued on, they would begin to diverge again, eventually traveling all the way around the cosmos to arrive back at our ship from the opposite direction. What this really means is that in a closed universe, the very rules of geometry are different on a grand scale. The angles of a vast cosmic triangle would add up to more than 180 degrees. Straight lines are not truly straight, but are infinitesimally curved paths called geodesics. It is a universe that is fundamentally, beautifully, and invisibly round. There's a quiet sense of intimacy to this idea. It suggests a cosmos that, for all its unimaginable vastness, is ultimately a single connected place. It isn't a chaotic, infinite sprawl, but a unified, coherent, and perhaps even cozy home. It is a finite room, but with walls that are seamlessly connected to one another, so the journey never ends. It is a place that feels endless, but is ultimately knowable, and this strange curved geometry leads to the single most wondrous and mind-bending consequence of them all. It is the first great ripple from our core idea. That first wondrous ripple is a direct consequence of this cosmic curvature, a possibility so strange and so beautiful it sounds like something from a dream. If our universe is indeed a finite, closed hypersphere, then light, given enough time, could make a complete circuit. A photon sent out into the void in one direction could circumnavigate the entire cosmos and return to its starting point from the exact opposite direction. This leads to an incredible thought. What if we could build a telescope powerful enough not just to see distant galaxies, but to see a light that has completed this grand cosmic lap? What would we see? The answer is as simple as it is profound. We would see the back of our own head. Let us try to picture this together. Imagine we are in an observatory, a quiet circular room high on a lonely mountaintop. The air is thin and cold, and the silence is broken only by the gentle hum of our incredible machine. We are looking not through an eyepiece, but at a vast, dark screen, a window onto the deepest and oldest parts of the cosmos. Tonight we are pointing our telescope at a seemingly empty patch of the sky, a region of profound, uninterrupted blackness between the familiar, glittering galaxies. We are waiting for a very specific kind of light from the most distant source imaginable, ourselves. We are looking for photons that left our own galaxy, the Milky Way, billions of years ago. Photons that streamed out from our spiral arms, away from Earth, in the opposite direction of our telescope's gaze. These ancient messengers traveled out into the deep, past Andromeda and the great galactic clusters. They journeyed on, across the expanding void, for billions of years, their paths gently guided by the unseen curvature of space-time. They crossed the halfway point of the universe, and then began the slow, long journey home, converging back towards their origin. And tonight, after an eon-long pilgrimage, they are finally arriving. They are entering the lens of our telescope, carrying with them a picture of their source. As the image slowly resolves on the screen, it is not a picture of a distant, alien galaxy. It is a faint, ghostly, and impossibly ancient image of our own home. We would be seeing the Milky Way, not as it is today, but as it was when the light began its journey. We would be looking at our own cosmic past. It would be like standing in a hall of mirrors, where the reflections are not of this instant, but of 1,000 different moments in your own history. If we could refine the image, if we could zoom in with impossible precision, we might see our own sun, a younger, slightly different star, and orbiting it, we might just be able to make out a faint pale blue dot. Earth. We would be seeing our own planet, as it was in its deep primordial past, perhaps even before life had begun. What this really means is that in a closed universe, the sky is not a window, but a map of time, a map that eventually folds back to include the cartographer. There is a quiet, poetic symmetry to this. It suggests a universe that is self-referential, a cosmos that contains its own reflection. It would mean that the light from every star, every event has been painting itself over and over again onto the canvas of the sky, creating a cosmic echo of all that has ever been. This idea of seeing ourselves in the distance is still a beautiful speculation, but we have found something real that acts in a similar way. Not a mirror, but a faint glowing fog at the very edge of our sight. That faint glowing fog is the oldest light in existence, a real and observable boundary at the edge of our cosmic ocean. It is called the cosmic microwave background, or the CMB. It is not a reflection of our own galaxy from the distant past, but something even more profound. It is the afterglow of creation itself. It is the very edge of our observable universe, that gentle, luminous wall of time we spoke of earlier, now rendered visible. To truly feel its presence, let us return to our quiet, dark ship, floating in the cosmic sea. We have been so focused on the distant pinpricks of light from galaxies, we have failed to notice a much softer, gentler light that fills the entire sky. Imagine we turn off all the ship's internal lights, and we let our eyes adjust to the perfect darkness. We have a special instrument on board, a sensitive radio telescope that can see not the sharp light of stars, but the faint, cool glow of microwaves. We point it at a patch of sky that appears completely empty to our eyes, a deep velvety black between the constellations. We are expecting to register perfect silence, the cold absolute zero of empty space. Instead, our instrument detects a faint, persistent, and almost perfectly uniform hum, a soft, gentle hiss of energy. It is coming from every direction, at all times, with the same steady, quiet intensity. It is as if the entire universe is faintly glowing, bathed in the warmth of a fire that went out long, long ago. This glow is the cosmic microwave background. It is the residual heat from the Big Bang, an echo of the moment the universe was born. For the first few 100,000 years of its existence, the universe was an incredibly hot, dense, and opaque fog. It was a roiling plasma of particles and energy, so dense that light could not travel freely. A single photon would be emitted, and an instant later, it would be absorbed and re-emitted, trapped in an endless game of cosmic pinball. The entire universe was like the inside of a star, a brilliant, glowing cloud. Then, as the universe expanded and cooled, it reached a critical moment, a moment of transition, like water freezing into ice. The hot plasma cooled enough for stable atoms to form. Suddenly the fog cleared. For the very first time, light was set free, and the universe became transparent. The photons that were released in that instant have been traveling across the cosmos ever since, their energetic, brilliant light stretched by the expansion of space over 13.8 billion years, from a searing white-hot glow into the faint, cold, invisible microwaves our telescope now detects. A Princeton scientist named Robert Dicker, along with his team, had theorized in the 1960s that this light must exist, and they were building an instrument to find it. But just a few miles away, two radio astronomers, Arno Penzias and Robert Wilson, found it by accident. They were trying to eliminate a persistent, annoying hiss in their large horn antenna, a noise that wouldn't go away no matter where they pointed it. They even cleaned out pigeon droppings, thinking it was a mundane, earthly interference, but the hiss remained. That quiet, unwanted noise was the sound of the Big Bang, the oldest story in the universe, whispering from every direction at once. What this really means is that when we look at the CMB, we are looking at the surface of that ancient glowing fog bank. We are seeing the wall of our observable universe, a wall made of light. We can't see past it, not because there's nothing there, but because the universe beyond that point in time was opaque. The shape we see, this great sphere of ancient light surrounding us, tells us something profound, and the tiny subtle variations in its temperature, like faint clouds in the afterglow, hold the key to understanding not just the past, but the ultimate fate of the universe. Those faint subtle clouds in the afterglow, the tiny almost imperceptible variations in the temperature of the cosmic microwave background, are more than just an ancient echo. They are the seeds of everything that exists today. The slightly warmer, denser patches are the places where gravity would take hold, the fertile grounds from which the first stars and galaxies would eventually sprout. But these patterns also hold a deeper secret, a clue not just to our cosmic past, but to our ultimate future. They contain the answer to one of the greatest questions of all: what is the final fate of the universe? For it turns out that the overall shape of the cosmos and its ultimate destiny are one and the same. Geometry is fate. To understand this deep connection, let us imagine a simple earthly act. Picture yourself standing in an open field on a cool, clear night. The air is still, and the sky above is a vast, dark tapestry of stars. You bend down and pick up a small, smooth stone, its weight familiar and solid in your hand. You look up, take a deep breath, and you throw the stone as hard as you can, straight up into the sky. Now, watch its journey. For a moment it is a powerful ascending blur, fighting against the invisible pull of the earth. But what happens next? There are only three possibilities. The first and most familiar is that the earth's gravity is simply too strong. The stone rises, slows, and for a fraction of a second it seems to hang in the air, caught in a moment of perfect stillness. Then, inevitably, it begins to fall, returning to the ground from which it came. The second possibility is that you could throw the stone with such incredible superhuman force that it overcomes Earth's gravity entirely. It would soar upwards, past the thin layers of our atmosphere, and into the blackness of space, continuing on forever, always slowing but never stopping. It would escape. The third possibility is the most delicate, the most precise. Imagine you could throw the stone with the exact perfect speed, the escape velocity. It would travel away, its speed dwindling, getting slower and slower and slower, but never quite falling back. It would be forever balanced on the knife's edge between returning and escaping. These three paths are the three possible fates of our universe. The initial expansion of the Big Bang was the great upward throw. The combined gravity of all the matter and energy in the cosmos is the force pulling it all back together. The entire story of the universe is a competition between these two forces. If there is enough stuff, enough mass, enough energy, enough gravity, then like the first stone, the universe's expansion will one day slow, stop, and reverse. Space will begin to contract, galaxies will rush back towards each other, and everything will end in a fiery big crunch. This corresponds to a universe with a closed, spherical shape. If there isn't enough stuff, not enough gravity, then like the second stone, the universe will expand forever, becoming colder, darker, and emptier in a big freeze. This corresponds to an open, saddle-shaped universe. And if the amount of stuff in the universe is precisely perfectly balanced at a value known as the critical density, then our cosmos is like that third stone. It will expand forever, but the rate of expansion will slow over the eons, approaching zero but never quite reaching it. This corresponds to a universe that is perfectly flat. The quiet genius of Albert Einstein, with just a pencil and his thoughts on the nature of gravity, was the first to realize this. His equations showed that the amount of matter fundamentally dictates the geometry of space-time. What this really means is that the total weight of the cosmos dictates its final chapter. The shape of space is its story, and so the cosmos presents us with three possible paths, three potential shapes for reality. The first, and perhaps the one that feels most familiar to our intuition, is a universe that is perfectly balanced. Let us now explore that first possibility. The universe balanced on a knife's edge. This is the cosmos that corresponds to the stone thrown with the perfect, precise escape velocity. It is a universe that expands forever, but its expansion is forever slowing, always approaching, but never quite reaching, a final, graceful stillness. This is the flat universe, and the word flat can be a little misleading. It doesn't mean our universe is two-dimensional, like a pancake. It means that on the largest possible scales, its geometry is the familiar, comfortable geometry we learnt in school. It is a universe with no overall curvature. To feel this, let us return to our analogy of a two-dimensional world. But this time, instead of a sphere, our world is an infinite, perfectly flat sheet of paper. Imagine yourself as a being living on this endless white plain. The world stretches out in every direction forever. There are no hills. There are no valleys. There is no gentle global curve that will eventually bring you back home. There is only a profound, unending, and perfect flatness. You decide to take a journey. You pick a direction and walk in a perfectly straight line. You walk for 1,000 years, 1,000,000 years. The scenery might change, with clusters of ink block galaxies appearing and receding, but the ground beneath your feet is always fundamentally the same. You will never ever return to your starting point. Your journey is infinite. you decide to conduct an experiment. You and a friend stand side by side, and you both begin to walk forward in two perfectly parallel lines. You travel across this infinite paper landscape for an eternity, and the distance between you and your friend will never change, not by a single inch. Your paths will never meet, and they will never diverge. They will remain perfectly parallel forever. If you were to draw a giant triangle on this page, with sides that are billions of light years long, the sum of its three angles would always be exactly 180 degrees. This is the quiet, predictable, and reliable world of Euclidean geometry. It is the universe our intuition expects. What this really means is that our own three-dimensional space would behave in the same way. A flat universe is one that is not warped or curved on a cosmic scale. For all its local wrinkles caused by the gravity of stars and galaxies, like small dimples on the paper, its overall global nature is one of straightness. The light from distant galaxies travels to us without being bent by any overarching cosmic curve. It is a universe that is, in a sense, simple. It is infinite in extent, and it will be infinite in its duration, expanding forever into a colder, quieter future. There is a clean, almost austere beauty to this idea. It is a cosmos of perfect equilibrium, where the outward push of the Big Bang is in a perfect eternal balance with the inward pull of gravity. It is the universe that has exactly the critical density of matter and energy required to strike this delicate pose. In other words, it contains just enough stuff to slow the expansion down forever, but not quite enough to ever reverse it. It is a universe that is forever coasting, its initial momentum slowly, gracefully, bleeding away over the eons. This vision of a perfectly balanced cosmos has a clean, quiet elegance, but it is a universe balanced on a knife's edge, and this leads us to a calmer, deeper question. What if there isn't quite enough matter to hold the cosmic canvas perfectly taut? But what if that perfect balance is an illusion? What if the universe doesn't have quite enough matter to gently rein itself in? This brings us to the second possibility, the second path our stone can take on its journey into the night. This is the stone thrown with too much force, the one that will not only escape Earth's gravity, but will continue to fly away forever, its journey endless. This is a universe where the outward push of the Big Bang decisively, effortlessly, wins the cosmic tug of war. This is the open universe, and its shape is perhaps the strangest and least intuitive of them all. It is a universe of negative curvature. To picture this, let us once again imagine a two-dimensional world, but this time it is not a flat sheet or a gentle sphere. Instead, imagine the surface of a saddle, the kind you would place on a horse's back, stretching out infinitely in all directions. Or, for a more delicate image, picture the graceful, complex curve of a Pringle potato chip, magnified to an impossible scale. This is a shape that curves in two different opposing directions at the same time. Along the length of the saddle, it curves downwards, but across its width, it curves upwards. It is a landscape of endless, rolling, hyperbolic hills. Now imagine you are a tiny being, living your life on this infinite, saddle-shaped surface. The world around you feels profoundly different. Unlike the sphere, which curves inward and feels closed, this world seems to constantly open up, to expand away from you in every direction. The ground itself feels like it is perpetually stretching. Let's repeat our experiment. You and a friend stand a few feet apart, and you both begin to walk forward in what you believe are two perfectly parallel lines. On a flat plane, you would stay together. On a sphere, you would eventually meet. But here, on the saddle, the most curious and lonely thing happens. Your two paths begin to diverge. The strange, open curvature of the space between you gently, inexorably, pushes you apart. At first, the separation is tiny, but over a long journey, you would find yourselves drifting further and further from each other. Your voices would no longer carry. You would become a distant speck on your friend's horizon, and they on yours, each of you continuing on your own solitary, unending journey into an ever-widening expanse. This is a universe built for separation. If you were to draw a massive triangle here, its sides would bow outwards, and the sum of its angles would be less than 180 degrees. The space itself seems to contain more room than a flat universe. This strange, mind-bending geometry was first imagined in the 19th century by quiet, brilliant mathematicians like Janos Bolyai and Nikolai Lobachevsky. They worked in isolation, daring to defy 2,000 years of classical geometry, crafting rules for these impossible saddle-shaped worlds that were seen as little more than mathematical games. And yet, their abstract dreams turned out to be a genuine physical possibility for the shape of our entire reality. What this really means is that our own three-dimensional space could be a higher-dimensional version of this saddle, a universe that is infinite, open, and forever expanding at a rate that never slows to zero. It is a cosmos where gravity is too weak to ever bring things back together. The clusters of galaxies, like our two lonely travelers, would be carried apart into an endless, cold and dark future. There's something quietly melancholic about this idea. It suggests a universe of profound, growing solitude, where the distances between things are destined to grow forever, until every galaxy is a lost island in an uncrossable void. Yet this vast, lonely expanse is not the only alternative. There is a third shape, a third fate, one that feels less like an endless escape and more like a gentle return home. That third and final possibility is a gentle, comforting return. It is the path of the stone that we first imagined, the one that rises with power, but ultimately, gracefully, succumbs to the pull of home and falls back to earth. This is the universe where the inward pull of gravity is the undisputed champion of the cosmos. It is a universe with enough mass and energy, not only to slow the expansion, but to one day halt it entirely, and then, slowly, majestically, pull everything back together. This is the closed universe, and its shape is the familiar, elegant, and beautiful form of the sphere. We have visited this shape before as our core idea, but let us return to it now with a new understanding, seeing it not just as a curious possibility, but as one of the three great destinies of the cosmos. Let us imagine ourselves once again as two-dimensional beings living on the surface of an immense polished globe, but this time we are aware of its true nature. We know that our world, which appears flat to our senses, is in fact gently and uniformly curved in upon itself. We know it is a place that is finite, but without boundary. It is a home, a single, complete and unified world. Let's repeat our journey one last time. We and our friends stand near the equator of our spherical universe, a few feet apart, and we both begin walking due north. We are walking in parallel lines. At first, for many miles, our paths seem to hold their distance perfectly. Our world feels flat, but as we continue on our long journey, the subtle positive curvature of our world begins to work its magic. Without either of us changing our direction, we find ourselves slowly, gently, drifting closer to one another. The space between us is shrinking. We continue on, and eventually, after a grand pilgrimage to the pole, our two parallel paths will meet. We will arrive at the same point, from two different starting positions. This is a universe built for reunion. It is a cosmos where straight lines, extended far enough, become great, looping circles. It is a world where a triangle drawn across its surface will have angles that add up to more than 180 degrees, its sides bowing gently outwards with the curvature of the sphere. There is something deeply satisfying and complete about this geometry. It speaks of a universe that is self-contained, a place that, for all its vastness, you could one day come to know in its entirety. It is not an infinite, unknowable sprawl, but a single, traversable cosmic island. For much of the 20th century, many astronomers and physicists, including Albert Einstein, felt that this was the most elegant and philosophically pleasing model of the universe. The brilliant Dutch astronomer Willem de Sitter explored this idea deeply, imagining a cosmos that was a perfect, timeless sphere, held in a delicate, static balance. Einstein's own early models showed that a universe filled with matter should curve this way, that gravity should naturally pull space into a closed form. What this really means is that our three-dimensional space could be the surface of a four-dimensional hypersphere. It would be a universe that contains a finite amount of volume, a countable number of galaxies, a limited quantity of stuff. But it would have no edge. Its fate would be as dramatic as its birth. After billions of years of expansion, the cosmic tide would turn. The redshift of distant galaxies would slowly transform into a blue shift as they began to rush toward us. The universe would grow warmer, brighter and smaller, culminating in a final fiery collapse, a big crunch that would be the mirror image of the Big Bang. So we have our three shapes, our three destinies, the open saddle, the closed sphere, and the flat, balanced plane. But the next step is not one of abstract geometry. It is a question of a calmer, deeper measure. So we are left with these three magnificent possibilities, the infinite, lonely saddle, the finite, intimate sphere, and the perfectly balanced, infinite plane. 3 potential shapes for reality, 3 different destinies for the cosmos. But how do we choose? How do we know which of these 3 grand cosmic rooms we are actually living in? The answer, it turns out, does not come from drawing triangles across the sky, but from something much more fundamental. It comes down to a single number. The decision rests on a cosmic scale, weighing the entire universe to see if it is heavy enough to fold in on itself or so light that it will fly apart forever. To understand this, let us create a picture of space in our minds. Imagine we are in a vast, silent and dark workshop. In the center of the room, floating in the air, is a giant circular frame holding a sheet of the blackest, most flexible rubber imaginable. It is stretched perfectly taut, shimmering faintly in the dim light. This rubber sheet is the fabric of space-time. It is flat, balanced, and waiting. This represents the universe in its potential state, a blank canvas for reality. Now, we will play the role of creation. In our hands, we have a bag of fine, glittering dust, like crushed diamonds. Each speck of dust represents a star, a galaxy, a cloud of gas, a piece of matter and energy. First, let's try to create a flat universe. With extreme care, we begin to sprinkle the glittering dust onto the rubber sheet. We add just enough to give it a slight, uniform tension. A single speck creates a tiny dimple, but when we distribute the dust perfectly evenly, the sheet as a whole remains flat. The combined weight is exactly right to counteract the tautness of the rubber, holding it in a state of perfect, beautiful equilibrium. This is the universe with the critical density. It has precisely the right amount of stuff to balance the outward energy of its own expansion. It is a cosmos held in a moment of sublime, eternal poise. Now, let's clear the sheet and try again. This time, we are going to create a closed universe. We take handfuls of the glittering dust and a heavier, darker sand, and we pour it generously onto the center of the sheet. Watch what happens. The fabric of space-time immediately begins to sag under the immense weight. A deep, bowl-like depression forms, and the entire sheet curves downwards. The more we add, the more it sags, its geometry becoming undeniably spherical. If we could add enough, the weight would become so great it would pull the circular frame itself inwards, closing into a ball. This is a universe with a density greater than critical. Its own gravity is so powerful, it overwhelms the expansion and curves space back in on itself. Finally, we try one last time. We clear the heavy sand away, and this time, we add only the faintest, most delicate whisper of dust, far less than is needed to pull the sheet taut. The rubber fabric is now too loose, too energetic for the tiny amount of weight holding it down. It doesn't sag. Instead, it springs up in places, ruffling and warping into a complex open shape like a saddle. This is our open universe, with a density less than critical. There is not nearly enough gravity to rein in the expansion, so the fabric of space flies open, expanding forever. What this really means is that the fate and shape of our universe are determined by its contents. The cosmos is its own architect. The Russian mathematician and meteorologist Alexander Friedman was one of the first to truly see this in the pure language of mathematics. Working in the early 1920s, in a country rocked by war and revolution, he quietly solved Einstein's equations and discovered that they allowed for these 3 dynamic realities, a universe that could expand and contract like a lung or expand forever. He saw that destiny was a question of density, and so our grand, abstract question about the end of space has become a practical one, a cosmic accounting problem. We must survey the heavens, counting the galaxies, measuring the dark matter, and tallying the mysterious dark energy to see if it all adds up to that single magical number, the critical density. But the light from the dawn of time carries one more message, a final verdict written in its faint and ancient glow. That ancient light, the faint afterglow of the Big Bang, does indeed carry a verdict. It is a message that has traveled for nearly 14 billion years, and to read it, we had to build some of the most sensitive and ambitious instruments in human history. We sent silent, patient explorers into space, probes named WMAP and later Planck, to drift in the cold darkness, far from the Earth's warmth and noise. Their sole purpose was to stare, for years on end, at that faint primordial glow, the cosmic microwave background, and to create the most detailed map of its subtle ancient clouds. Imagine we are in a quiet, dark control room, the collective hush of 1,000 scientists held in the air. On a vast, curved screen before us is the final map from the Planck satellite. It is a beautiful, mottled oval of orange and blue, looking like a pointillist painting of a cosmic egg. These are not colors our eyes could see. They represent impossibly tiny temperature differences in the microwave sky, variations of just a few millionths of a degree. This is a baby picture of the universe, and hidden within its patterns is the answer to the shape of everything. The method is one of pure, beautiful geometry. Scientists could calculate with remarkable precision the actual physical size of the largest of those warm and cool spots in the primordial fog when the light was first released. This known size became our cosmic yardstick, a ruler 380,000 light-years long, left behind in the early universe. All we had to do was measure the apparent asterisk size of these spots on our sky today. The very fabric of space, over its long history, would act as a cosmic lens, bending the path of the light and distorting the image of our yardstick. If the universe were closed, like a sphere, the intervening space would have acted like a giant magnifying glass. The spots on our map would appear larger than our calculations predicted. If the universe were open like a saddle, the space would have acted as a demagnifying lens, making the spots appear smaller. And if by some chance the universe was perfectly flat, with no overall curvature, the spots would appear exactly the size our calculations told us they should be. There would be no distortion at all. For years the data streamed in, a faint whisper from 1,000,000 miles away, and as the final beautiful map came into focus, the verdict was delivered in a profound cosmic silence. The spots were the correct size. The cosmic lens was not magnifying, it was not demagnifying. It was a perfect, clear sheet of glass. The universe, to the absolute best of our ability to measure it, is flat. What this really means is that we are living in that third, perfectly balanced reality. The cosmic scale we imagined is not tipping one way or the other. The total density of matter and energy in our universe appears to be exactly, precisely, the critical density needed to keep it flat. The outward push of expansion and the inward pull of gravity are in a state of exquisite, unbelievable equilibrium. There is something quietly astonishing about this. It is the cosmic equivalent of throwing a stone into the sky and having it perfectly achieve escape velocity, not by a near miss, but with a precision to dozens of decimal places, and this perfect, simple answer is also the most unlikely one. The numbers whisper a different story, one of an impossible balance, a fine-tuning so extreme it borders on the miraculous. This simple, elegant answer that the universe is flat should have been a moment of quiet satisfaction, a neat and tidy conclusion to our cosmic survey. But instead, it is the beginning of one of the deepest and most profound mysteries in all of cosmology. The verdict of flatness did not bring closure, it brought a quiet, creeping sense of unease, because a flat universe, while simple to describe, is the single most unlikely of the three possibilities. In fact, it is so improbable that it should be statistically impossible. This is what is known as the flatness problem. To feel the weight of this problem, let us return to our quiet, dark workshop. But this time, our experiment is one of impossible delicacy. On a perfectly smooth, polished wooden table, you place a single ordinary pencil. Your task is not to roll it or to weigh it, but to balance it. You must stand it upright, perfectly, on its sharpest point. You hold your breath. The air in the room is utterly still. With the steadiest hands imaginable, you try to find that single infinitesimal point of perfect equilibrium. The pencil wavers, its shadow dancing in the dim light. For a fraction of a second, you think you have it. It hangs there, a tiny vertical tower, a monument to impossible balance. But then, the slightest tremor, a vibration from a passing footstep you didn't even feel, a single molecule of air bumping against its side, and the moment is broken. The pencil does not just wobble, it falls. It collapses completely, clattering onto the table and coming to rest, stable and secure, on its long hexagonal side. This is the crucial point. The state of being balanced on its tip is an unstable equilibrium. It is a state of profound, beautiful, but temporary perfection. The state of lying on its side, however, is a stable equilibrium. It is the natural, default, and final resting place for the pencil. Our universe is that pencil. The open, saddle-shaped universe and the closed, spherical universe are the two stable states. They are the cosmic equivalent of the pencil lying on its side. Any universe with even a tiny bit too much or too little density will naturally, inevitably, fall into one of these two shapes. The flat universe, however, is the pencil balanced perfectly on its point. It is the one state of perfect unstable equilibrium. For our universe to be flat asterisk today, asterisk, after 13.8 billion years of expansion, a process that would have magnified any initial deviation by an astronomical amount, is not like balancing the pencil for a second. It is like balancing the pencil on its tip for 14 billion years and finding it still standing perfectly upright. What this really means is that the universe must have been born with its density tuned to the critical value with an absurd, almost supernatural precision. In the first second of its life, if its density had been off by just 1 part in a quadrillion, a number so large it exceeds the number of grains of sand on all the beaches of the Earth, our universe would not be here. A fraction more, and it would have collapsed into a big crunch billions of years ago. A fraction less, and it would have flown apart so fast that not a single star, not a single galaxy could have ever formed. The American cosmologist Alan Guth was one of the first to be deeply troubled by this. The universe didn't just look flat, it looked, as he put it, unbelievably flat. It felt less like a discovery, and more like a clue to something deep we had missed. The perfect balance we see today is not an answer, but a quiet scream from the past, telling us that a crucial event is missing from our story. However, the simplest picture softly unfolds a second layer, a single powerful breath in the universe's first moments that may have made this balance inevitable. That single powerful breath is a theory known as cosmic inflation. It is a modification to the story of the Big Bang, a single breathtaking event that may have happened in the very first fraction of a second of the universe's life, and it has the power to make the impossible balance of our flat universe feel not just possible, but entirely inevitable. It is the missing chapter that makes the entire story make sense. To understand its power, we must imagine our universe not at its birth, but a moment before. Let us hold in our hands that small, dark balloon from before, but this time it is not perfectly smooth. It is a tiny, crumpled and highly creased thing, no bigger than a marble. Its surface is a chaotic mess of wrinkles and sharp folds, representing a universe that could have had any random high degree of curvature at its very beginning. It is the opposite of flat. It is a universe in its most natural, chaotic and untuned state. Now imagine that in the first flicker of existence, in a span of time so short it makes a nanosecond feel like an eternity, a mysterious energy field suddenly kicked in, and the balloon was inflated with an unimaginable explosive force. This was not a gentle, steady breath. It was a silent, explosive whoosh of expansion, stretching the fabric of space faster than the speed of light. The tiny, marble-sized balloon, in a fraction of a second, swells to the size of a galaxy. Watch what happens to those creases and wrinkles. The violent hyper-expansion pulls the rubber so taut that every flaw, every fold, every chaotic curve is smoothed out into a state of near-perfect flatness. The wrinkles are not gone, but they are now stretched across such a colossal area that they are rendered completely imperceptible. Now imagine a tiny microscopic ant living on the surface of this new galaxy-sized balloon. From its perspective, its world is a perfect, infinite, flat plane. It could walk for its entire lifetime and never detect the slightest hint of the balloon's true underlying curvature. The curve is still there, on a scale the ant could never hope to measure, but its local reality, its entire observable world, is for all intents and purposes perfectly flat. The American physicist Alan Guth, working late on a cold December night in 1979, was the first to realize the full power of this idea. He saw, in a sudden flash of insight, that if the early universe had undergone such a brief, dramatic period of hyperexpansion, its flatness today would be a natural consequence, not a miraculous coincidence. He scribbled furiously in his notebook, "Spectacular realization," feeling the pieces of the puzzle click into place. What this really means is that inflation didn't solve the flatness problem by delicately balancing the pencil on its point. It solved it by taking the entire table and the pencil and expanding them to the size of a continent. The pencil would still fall, but the ground it fell on would be, from its perspective, perfectly flat. our entire observable universe, everything we can see out to the cosmic horizon, is just one tiny, smoothed-out patch on a much, much larger cosmos that was born from this inflationary event. The universe isn't flat because it was born that way, but because it was made so colossal that any part of it we can see must now look flat. This beautiful solution makes our flat universe feel almost inevitable, and yet it also quietly redefines our search once more. For if our entire cosmos is just one hyperinflated patch, then the true end of space might be the gentle boundary where our calm, flat region meets a much larger and stranger cosmos just beyond our view. This grand idea of cosmic inflation, this single powerful breath at the dawn of time, does more than just solve a problem. It quietly, gently, and completely redefines our entire journey. Our search for the end of space has been transformed. We are no longer looking for the edge of a single, all-encompassing object. We are now like people who have just realized that the familiar room we have been exploring is just one room in an impossibly vast and unseen mansion. Our entire observable universe, the sphere of everything we can see out to the glowing wall of the past, may be just one tiny smoothed-out bubble in a much larger, much stranger reality. To truly feel this shift, imagine you were born and have lived your entire life in the very center of an immense, perfectly flat prairie. The sky above you is a great blue dome, and the horizon in every direction is a perfect, clean circle. The world, as far as you can see, is an endless sea of tall golden grass, whispering in the wind. This is your universe, and because the prairie is so vast, so utterly enormous, you have concluded that the entire world must be a flat, infinite plain of grass. It is a reasonable conclusion. It is all you have ever seen. It is all your instruments can measure. The horizon is the end of your world, not because it is a wall, but because it is the limit of your sight. But we, from a higher vantage point, know the truth. We know that far, far beyond your circle of sight, the world is not all prairie. We know that if you could travel for 1,000 years in one direction, you would eventually come to the foothills of a towering, snow-capped mountain range, a feature with immense and complex curvature. And if you traveled in another direction, you would find the shores of a vast, deep ocean, a world with its own strange liquid geometry. Your flat prairie is not the entire world. It is just one geographical feature, one calm region in a much more diverse and complex landscape, a landscape you cannot even begin to imagine because your horizon is too close. Our universe is this prairie. The violent stretching of inflation created a region of space-time so colossal that our little patch of it, our entire observable cosmos, now appears perfectly flat to us. The end of space in this new picture is no longer the ultimate boundary of existence. It is simply the horizon of our local, inflated region. Beyond that horizon, the greater cosmos could be anything. It could be wildly curved, like those distant mountains. It could have different properties, different textures. We are living in the quiet, calm, flat center of our own cosmic patch, and we are mistaking it for the entirety of reality. What this really means is that the question what happens at the end of space has become a local question. We are asking what happens at the edge of our neighborhood, not the edge of the world. The Russian-American physicist Andrei Linde, one of the pioneers of this idea, imagined a cosmos where inflation never truly stops. It is a process of eternal inflation, where new bubble universes, new prairies, are constantly springing into existence from a chaotic, ever-expanding foam. Our universe is just one of those bubbles, a single, quiet island of stability in an infinite, roiling sea of creation. There is a quiet humility in this idea. The cosmos we thought was everything might just be a single grain of sand on an infinite beach. Our search for the end has led us to the possibility that our universe has an edge, but it is an edge that opens into something else entirely. But the map bends in a way we don't expect. Even if our prairie is all there is, it may not be as simple as it looks. Even if our flat, grassy prairie is all there is, it may not be as simple as it appears. The map of our universe can bend in a way that has nothing to do with the familiar idea of curvature. For centuries, we have been focused on geometry, the study of shape and distance, of whether space is curved like a sphere or a saddle. But there is a quieter, stranger, and more subtle property to consider. It is called topology, and it is not about the shape of the floor, but about how the room is connected to itself. It is the study of which doors lead to which hallways, of how the boundaries of a space are stitched together. To grasp this idea, let us leave the prairie and imagine ourselves inside a simple old video game. The world is a flat, two-dimensional screen. The background is a perfect inky black, and the only features are the glowing geometric lines of a simple maze. The only sound is a low, gentle electronic hum, the quiet pulse of this digital universe. You are piloting a small triangular ship, and you decide to find the edge of your world. You fly in a perfectly straight line, moving from left to right across the screen. You pass the familiar constellations of obstacles, and up ahead, you see the boundary, the right-hand edge of your reality. But as you approach it, you realize it is not a wall. There is no barrier to crash into. It is a shimmering, invisible threshold. You hold your course, and with no bump, no jolt, your ship simply passes through it. For a seamless single instant, you are gone from the right side of the screen, and in that very same instant, you reappear on the left. You have not turned around. You have not jumped across a vast external void. The right edge and the left edge of your universe are in fact the same place. You realize, with a sense of quiet wonder, that your world is not an infinite rectangle. It is a finite loop. It is a flat screen that has been seamlessly wrapped around, its edges connected. It has a finite area, but it has no boundary. It is a two-dimensional universe you could travel across forever. This is the essence of topology, and our own three-dimensional universe, even though our best measurements show it to be perfectly flat, could have this same strange and beautiful property. The left side of the cosmos could be seamlessly stitched to the right side. The top could be connected to the bottom, and the front to the back. If you were to fly your spaceship in a straight line for an almost unimaginable amount of time, you wouldn't hit a wall. You would simply quietly re-enter the universe from the opposite side, like a character in a video game. The cosmos would be a cosmic hall of mirrors, where the light from a single galaxy could wrap around space and appear as a second, fainter galaxy in another part of the sky. What this really means is that a flat universe is not necessarily an infinite one. Geometry tells us the canvas is flat, but topology tells us it might be rolled up and connected in ways we cannot see. There's something quietly profound about this. It allows for a cosmos that is both flat, as our observations suggest, and finite, which feels somehow more complete, more knowable. It separates the idea of endlessness from the idea of having no end. The journey can be endless, even if the place is not. And this leads us to a calmer, deeper question. What would it feel like to float in the heart of the most famous of these looping, folded shapes? Of all the ways a flat universe could be connected to itself, the most famous, the most studied, and the most beautifully simple is the three-dimensional torus. To our minds, the word torus conjures the image of a donut, a familiar, friendly shape with a hole in the middle. And while our universe wouldn't look like a pastry floating in some higher space, the fundamental properties of that shape, the way its surfaces curve and connect, provide a perfect analogy for what it would feel like to live inside it. It would be a universe that loops, a cosmos where the journeys are endless, but the destination is always eventually home. Let us return to the quiet cockpit of our small ship, floating in the deep, silent darkness. In this toroidal universe, the space immediately around us is perfectly flat. There is no strange curvature to distort our view. The nearby galaxies look just as they should. The laws of physics are stable and predictable. But as we gaze further out, into the truly deep cosmic distances, something quiet, strange and beautiful begins to happen. You are looking at a particularly majestic spiral galaxy, billions of light years away. You study its graceful, swirling arms, its glowing core. Then, you turn your gaze to a completely different part of the sky, and you see it again, the exact same galaxy. It is not a similar one, it is an identical twin, down to the last stellar nursery and dust lane, perhaps appearing slightly fainter, or from a slightly different angle, a ghostly echo of the original. You scan the heavens with your telescope, and the pattern begins to reveal itself. The sky is a tapestry woven from a single, repeating tile. The great clusters of galaxies are not unique islands in the void, but a recurring motif, a cosmic wallpaper that tiles the entire universe. This happens because in a torus-shaped cosmos, the light from a single object has many different paths it can take to reach your eyes. It can travel the short direct path, giving you the bright primary image of the galaxy. But it can also travel the long way around, looping through the universe's connected boundaries once, or twice, or 100 times, before finally arriving at your ship. Each of these longer journeys creates a fainter, older, ghost image of the same galaxy in a different part of the sky. What this really means is that in a toroidal universe, the concept of a single location becomes wonderfully ambiguous. Over there is also over here, just seen from the long way around. The universe is a finite room, but its walls are perfect, seamless mirrors, reflecting the room's contents back on itself to create the illusion of an infinite hall. The cosmos would be filled with these celestial echoes, phantoms of our own cosmic neighborhood appearing as distant strangers. We might even, in theory, see a faint, ghostly image of our own Milky Way, not as a reflection from the past as in the hypersphere, but as a true reflection in space, an echo of our present self that has circumnavigated the whole of creation. There's something quietly poetic about this idea. It suggests a universe of immense, almost dizzying complexity that is born from an underlying finite simplicity. It would be a cosmos that, for all its phantom images and strange repetitions, is ultimately knowable. You could in principle map the entire thing, because all you would need to do is map one fundamental repeating block. It is a universe that is both endlessly surprising and deeply fundamentally familiar. This vision of a looping, mirrored cosmos remains a beautiful and dizzying possibility, but the search for its proof is a quiet and patient one, and the next clue we must look for sits in the background noise. The search for these cosmic echoes, for a final definitive proof that we live in a looping finite universe, is one of the quietest and most patient quests in modern astronomy. We cannot simply look for repeating galaxies, because the time it would take for their light to circumnavigate the cosmos is so vast that we would be seeing a much younger, fainter, and differently oriented version of the galaxy, making it almost impossible to identify as a perfect match. The cosmic wallpaper is too faded, its patterns too stretched and aged to be easily read, but there is one canvas, one ancient tapestry, that might just hold the secret. We must return to that faint, gentle glow that fills all of space, the cosmic microwave background. Imagine we are back in that quiet control room, looking at the beautiful mottled map of the early universe from the Planck satellite. This map is not a picture of galaxies. It is a snapshot of the universe when it was just a baby, a simple, hot, glowing fog. This makes it the perfect place to look for a repeating pattern. The universe was younger, smaller, and the patterns of warm and cool spots were simpler. If our universe is a finite, looping torus, then the pattern of spots on one side of this CMB map should be connected to the pattern on the other. It would be as if the map was printed on a piece of paper that was then rolled into a cylinder, and then that cylinder was bent around to form a donut. The patterns would have to match up at the seams. The search for these matching patterns is a subtle and delicate art. Astronomers have developed incredibly complex computer programs to scan the CMB map, looking for any sign of these hidden symmetries. The main technique is to search for pairs of giant matching circles on opposite sides of the sky. These circles would be the places where the spherical shell of our observable universe intersects with itself, a consequence of the universe being smaller than our field of view. Imagine blowing a smoke ring in a mirrored room. You would see the ring, and you would see its reflection. These circles in the CMB would be the cosmic equivalent of that reflection, a sign that the light from the early universe has looped back on itself. A team led by the cosmologist Jean-Pierre Luminet created a sensation in the early 2000s by proposing a different, even more elegant topological shape, a dodecahedron, a 12-sided solid with its opposite faces connected. They argued that this specific shape beautifully explained some of the largest, strangest anomalies in the CMB data, the things that didn't quite fit the standard, flat, infinite model. It was a tantalizing hint, a beautiful possibility that the universe was not just finite, but had a specific and rather elegant structure, like a cosmic crystal. So far, however, the search has been inconclusive. The patterns are subtle, and the cosmic noise is significant. While some tantalizing hints have been found, there is no definitive smoking gun proof that our universe is a cosmic hall of mirrors. The data from the Planck satellite has placed powerful constraints on these ideas, suggesting that if the universe is a torus, it must be a very large one, with its looping scale at least comparable to the size of the observable horizon. This means we might be living inside a finite, repeating cosmos, but one that is so vast we can only see a single unique tile of the wallpaper. What this really means is that we are living on the edge of our own knowledge. We have pushed our understanding to the point where geometry and topology offer us these incredible, mind-bending possibilities, but the final definitive evidence remains just beyond the reach of our instruments. Our search for the end has brought us to a place of profound and beautiful uncertainty. And this leads us to a calmer, deeper question, one that takes us from the realm of the observable into the purely speculative. If our universe is a single room, however strangely connected, could there be other rooms? That quiet, beautiful uncertainty is the perfect doorway into the purely speculative. We have traveled to the edge of what our instruments can test, and now we must journey forward with our imaginations, guided by the strange and wondrous logic of the mathematics itself. The idea of cosmic inflation, which so elegantly flattens our universe, contains a seed of something far grander and far stranger. It suggests that the birth of our universe may not have been a singular, unique event, but a common, perhaps even constant occurrence in a much larger eternal drama. To feel this, let us imagine we are not on a ship or in a room, but floating in a place of pure potential. There is no up or down, no before or after. There is only a vast, endless ocean of the inflationary field itself, a quantum foam of pure, energetic space-time. This is the metaverse, the raw material from which universes are born, and this ocean is not calm. It is in a state of perpetual, silent, and ferociously rapid expansion. It is a sea that is forever growing, its own shores rushing away from its center faster than the speed of light. Now watch this ocean carefully. It is not perfectly uniform. Like any quantum field, it shimmers with tiny random fluctuations, and every so often, in a completely random location, one of these fluctuations will cause a tiny patch of this roiling ocean to calm down. In this small region, the inflationary energy suddenly decays, its furious, expansive power converting into a firestorm of matter and energy. This moment of decay, this sudden release of energy, is a Big Bang, and as it happens, a bubble forms in the cosmic foam, a new universe with its own space, its own time, and its own matter, expanding outwards into itself. Our entire universe, everything we have ever known, or seen or measured, is just one of these bubbles. The Russian physicist Andrei Linda, a true poet of theoretical cosmology, was one of the key visionaries of this idea, which he called eternal inflation. He saw a cosmos that was not a single, aging entity, but a kind of cosmic fractal, a structure that was endlessly self-reproducing, forever budding and blossoming with new worlds. The image he painted was not of a single event, but of a vast cosmic tree, with our universe as just one leaf on one branch among an infinity of others. What this really means is that the Big Bang was not the beginning of everything. It was just a local event. It was the moment our bubble formed, and the ocean of the inflationary field, the metaverse, continues to expand and churn, constantly giving birth to countless other bubble universes, each one an island in the ever-growing sea. We can never reach these other universes. We can never even see them. The space asterisk between asterisk the bubbles, the raw inflationary sea itself, is expanding so fast that it creates an uncrossable gulf. The other bubbles are receding from us faster than light. The end of our space in this picture is the boundary of our bubble, a theoretical shore we can never walk upon, looking out at an ocean we can never sail. There's something both incredibly grand and deeply humbling in this thought. It suggests that the story of our cosmos is just a single verse in an infinite poem. It is a vision of creation, not as a past event, but as an ongoing, eternal process. However, the deepest implication is not simply that other bubbles exist. It is that each one, born from that quantum chaos, might be a completely different kind of world. The end of our space, then, is merely the quiet, unseen shoreline of our own cosmic island. The shore of our cosmic island is where our journey takes its most speculative and most wondrous turn. For if eternal inflation is a cosmic tree, forever growing new branches, the deepest implication is not simply that other branches exist, but that each one might grow in a completely different way. The random quantum process that gives birth to each new bubble universe could also give it a unique and distinct personality. The fundamental constants of nature, the very rules of the game, might be different in each new world. To grasp this breathtaking idea, let us imagine a vast, silent, and infinite library. The air is cool and still, carrying the faint, dry scent of ancient paper and eternity. There are no other patrons, no footsteps, no whispers. The only light is a soft ambient glow that seems to come from the very air itself, illuminating endless rows of towering shelves that disappear into the misty, unseen heights. Each shelf is filled with an infinite number of books, each one bound in a different dark leather, their spines unmarked. This is the library of the multiverse. Each book is a universe. You reach out and gently pull a heavy volume from the shelf. Its cover is cool and smooth beneath your fingertips. You open it, but there are no words on its pages. Instead, as you look down, you see a cosmos unfold. In this first book, you see a universe where the force of gravity is 1,000,000 times stronger than our own. It is a violent, short-lived world where stars ignite and instantly collapse into black holes, a universe of crushing, fleeting intensity that never has a chance to form planets or life. You gently close the book and slide it back into its place. You choose another. In this one, the electromagnetic force is far weaker. The pages show a universe that is a vast, cold and formless fog. The bonds that hold atoms together never form, so stars can never ignite. It is a cosmos of eternal, drifting, lonely particles, a silent and unchanging sea of what might have been. You pull down another and another, a universe with 9 spatial dimensions, a tangled, complex place our minds cannot even picture. A universe with only 2, a flat cartoon world. A universe where the force that expands space, dark energy, is so powerful it instantly rips every atom apart the moment it is born. This is the cosmic landscape that physicists like Leonard Susskind have explored through the beautiful, complex mathematics of string theory. Their equations do not point to one single, unique solution for how a universe must be, but to a staggering number of possibilities, perhaps 10 to the power of 500, a number so large it exceeds all the atoms in our known universe. Each possibility is a valley in a vast, unseen landscape of potential, and each bubble universe that forms is like a ball that rolls down and settles in one of these valleys, adopting its local laws. What this really means is that the physical laws we have discovered, the elegant equations we have written to describe our world, are not universal, absolute truths. They are the local ordinances, the bylaws of our particular cosmic bubble. We exist because we happen to have been born inside a book whose story allows for it. We live in one of the rare volumes in that infinite library where the rules are just right for stars to shine for billions of years, for planets to form, for chemistry to work, and for life to emerge and wonder about it all. The end of space, then, is the boundary where our rules cease to apply. It is the silent, uncrossable shoreline of our home, looking out on a sea of worlds written in languages we could never hope to understand. And this leads us to a calmer, deeper question. What if our entire, vast, three-dimensional universe is just a beautiful and complex illusion, a projection on a distant wall? That distant wall brings us to perhaps the most abstract, the most challenging, and the most beautifully strange idea in all of theoretical physics. It is a quiet whisper from the very edge of our understanding, a speculative principle that suggests our entire, vast, three-dimensional universe, with all its depth, all its galaxies, all its seemingly solid reality, might be nothing more than a complex and beautiful illusion. It is a theory that suggests our cosmos is a hologram, a three-dimensional projection of information that is stored on a distant, two-dimensional surface at the very boundary of space. This is the holographic principle. To feel your way into this idea, let us return to that vast, dark and empty room from our very first beat. But this time, something is different. The room is no longer a void. The walls, floor and ceiling, which are impossibly far away, are not made of stone, but of a shimmering, pixelated film, like the surface of a colossal, high-resolution screen. The air in the room is still and silent. You are floating in the very center, and all around you the familiar, majestic cosmos unfolds. You see the Milky Way, the Andromeda Galaxy, the distant clusters, all rendered in perfect, breathtaking three-dimensional detail. It feels utterly real. You can feel the space, the depth, the distance. But as you begin to drift closer to one of the distant, shimmering walls, a quiet and strange transformation begins. The solid-looking galaxies start to lose their depth. They begin to look a little flatter, a little less defined. The closer you get to the wall, the more the illusion breaks down, and when you are right up against it, you see the truth. The three-dimensional galaxy is gone. In its place, on the flat surface of the wall, is a complex, shimmering, and chaotic-looking pattern of two-dimensional information, a sea of glowing bits and pixels that looks like a vast, intricate circuit board. The entire rich 3D world you just experienced in the center of the room is nothing but a complex projection, an image generated from this flat, two-dimensional source code written on the boundary of space. This radical idea first emerged from the mind-bending physics of black holes. Quiet, brilliant thinkers like Jacob Bekenstein and Gerard Hooft were struggling with a deep paradox about what happens to information when something falls into a black hole. They discovered, through pure mathematics, a stunning fact: the total amount of information that a black hole can contain is not proportional to its three-dimensional volume, as you would expect, but to the two-dimensional area of its event horizon, its surface. It was as if the entire 3D story of everything that had ever fallen in was somehow encoded on its 2D surface. What this really means, if the holographic principle is true, is that space itself, the very fabric of our three-dimensional reality, is an emergent property. It is not fundamental. The truly fundamental reality is a flatter, simpler, information-based reality that lives on the end of space, on the great cosmic boundary. We are the characters in a vast holographic movie, and we are mistaking the movie for the real world. The end of space is not a place you can travel to. It is the film on which our universe is recorded. There is a deep, almost mystical poetry to this idea. It suggests that the universe is, at its heart, made not of matter or energy, but of information. It hints at a reality that is far more like a thought than a thing, and it quietly, gently brings us back to the most fundamental question of all. But the next clue we must look for sits in the very weave of the cosmic tapestry. Is it a smooth, continuous painting, or is it made of individual, discrete threads? That question of threads brings our journey to its most intimate, most microscopic scale. We have soared to the speculative edges of the multiverse and the holographic boundary, and now we must turn our gaze inward to the very fabric of space itself. We have been speaking of space-time as a smooth, continuous canvas, a flexible rubber sheet that can bend and ripple. This is the universe as Albert Einstein saw it, a graceful, classical, and unbroken geometry. But the other great revolution of 20th century physics, quantum mechanics, whispers a different and far stranger story. It suggests that at the very smallest of scales, space may not be smooth at all. It might be a woven, pixelated, and granular thing. To feel the difference, imagine you are looking at a masterpiece of a painting in a quiet, sunlit gallery. From a distance, it is a perfect, seamless image. You see a beautiful, flowing river, its surface a smooth gradient of blues and silvers, its banks a soft, continuous curve of green. The painting is a single, unbroken reality. This is the Einsteinian view of space-time. But now, you step closer. You lean in, so your nose is almost touching the canvas. And as you do, the illusion shatters. The smooth, flowing river dissolves into a series of distinct individual brushstrokes. The soft green bank reveals itself to be a collection of discrete dabs of thick, textured paint. The continuous reality was an illusion, an effect created by the combination of a million tiny, separate elements. This is the quantum view of space. Theories like loop quantum gravity, pioneered by quiet, deep thinkers like Carlo Rovelli and Lee Smolin, explore this very idea. They suggest that space is not a passive backdrop, but a physical quantum field woven from an immense number of tiny, indivisible loops. These loops are the fundamental atoms of space. They are not asterisk in asterisk space, they asterisk are asterisk space. You cannot get smaller than one of these loops because there is no space for anything smaller to exist in. The smallest possible area is one loop. The smallest possible volume is a combination of these loops, a shimmering network of interconnected nodes called a spin foam. Reality, at its most fundamental level, is a tapestry. What this really means is that our smooth, continuous universe is just a low-resolution approximation of a much more complex digital reality. Time does not flow like a river, it ticks, like a cosmic clock, in discrete, indivisible moments. The smallest possible unit of time is the Planck time, a span so short that by comparison, the blink of an eye is a geological age. In this view, the end of space is not a distant boundary. It is right here, beneath our feet, under our skin. The end of space is the Planck length, the size of a single thread in the cosmic weave, a scale so small it is as far from us as we are from the distant galaxies. There is a profound, almost dizzying shift in perspective here. Our search for the ultimate boundary has taken us from the cosmic horizon, billions of light years away, to a scale trillions of times smaller than a single proton, right here, in this very room. It suggests that the vast empty space we see is, in fact, the most densely woven, most complex thing imaginable. The seeming nothingness of the void is a seething, shimmering foam of quantum geometry, a constant dance of creation and destruction at the most fundamental level. And this idea that the universe has a final, smallest scale leads us to a calm and final shift in our journey. Perhaps the most meaningful end is not an end of distance at all, but an end of time. Our long journey in search of an end has been a journey of distance. We have traveled across the expanding canvas of the cosmos, peered at the glowing wall of the past, and imagined looping through the very fabric of a finite space. But all this time, we have been thinking about an end as a place. What if the truest end, the most final and profound of all, is not a boundary in space, but a final chapter in the story of time? The flat, balanced universe that our evidence points to is one that will expand forever, and a universe that lasts forever has an almost infinite amount of time to change, to fade, and to find its final quiet form. To picture this, let us not imagine a journey, but a long, patient wait. Imagine we are sitting on the shore of a vast, impossibly deep and perfectly black lake. It is the final night. There is no moon, there is no wind, and in the sky above, there is only one single solitary star left. It is the last star in the universe, a tiny, ancient red dwarf that has been patiently sipping its fuel for trillions of years, and now its fuel is spent. We watch as its faint ruby light begins to soften, to dim. It is not an explosion, it is a gentle, graceful fade, like the last warm ember in a cooling fireplace. The last photon of its light leaves its surface, travels across the dark water, and reaches our eyes, and then it is gone. The sky is now perfectly, completely, and finally black. The star's passing was the last significant event in the history of the cosmos. Its fading warmth was the final ripple on the surface of the lake. We continue to sit in the profound stillness that follows. The silence is no longer an absence of sound, but a presence in itself. The temperature of the air, the water, and the dark shore becomes one, a uniform and universal coolness that is not cold, but simply neutral. The lake's surface, no longer disturbed by the gentle pressure of starlight, settles into a state of perfect mathematical smoothness. This is the universe in its final state of equilibrium. It is an image of the most profound and most complete peace imaginable. This is the quiet, distant fate known as the heat death of the universe, or more gently, the Big Freeze. It is the story's final quiet page, over timescales so vast they defy our imagination. All the stars will have burned out, their light fading into the growing darkness. The galaxies themselves, carried apart by the endless expansion, will have long since disappeared from each other's skies. The universe will become a vast, dark and lonely expanse of stellar remnants, dead stars, and wandering planets. And even these will not last. Over even longer timescales, matter itself may begin to decay, the very protons in an atom dissolving into whispers of light. The last great bastions of structure, the supermassive black holes, will slowly, patiently evaporate over trillions upon trillions of years, releasing their stored energy in a final faint sigh of Hawking radiation. What this really means is that the universe will eventually reach a state of maximum entropy. That is a scientific way of saying it will reach a state of perfect, uniform and uneventful quiet. It is not a death in the sense of a violent end, but a final deep and dreamless sleep. Every part of the cosmos will be the same temperature as every other part. No more heat will flow. No more work can be done. The story of cosmic evolution will be over. The great cosmic clock will not have stopped, but it will have nothing left to measure. It is an image of the most profound peace the cosmos can offer, and this quiet, endless stillness leads us to a calmer, deeper reflection on what such an eternity might feel like for us. This quiet, meditative image of an endless, fading universe brings us to a place of pure reflection. We have traveled through the science, the speculation, and the mathematics, and now we are left with a feeling, a philosophical echo. What does it mean for us, for our human hearts and minds, to live in a cosmos that might be truly, physically infinite? An open, flat, or saddle-shaped universe that extends forever in every direction, a story with no final page. Does this idea feel terrifying, or does it feel strangely, deeply comforting? For some, the thought of the infinite is a source of profound loneliness. To feel this, let us imagine ourselves back on that small, quiet ship, floating on the dark, cosmic ocean. But now, we know the ocean is truly endless. There is no other shore. There is no final harbor. The distant, glittering lights of other galaxies are not just islands we might one day reach, but islands that are being carried away from us on an eternal, expanding tide, destined to one day disappear from our view entirely. In this vision, humanity is a tiny, flickering candle in an infinite dark cathedral, and the wind is rising. It is a feeling of cosmic insignificance, a sense of being utterly, hopelessly lost in an abyss of unimaginable scale. Our lives, our history, our entire world become a fleeting, meaningless speck in an endless, indifferent void. But there is another way to feel the infinite, a gentler, more peaceful perspective. Let us stay on our ship, but change our frame of mind. The vastness of the ocean is not a threat, but a promise. It is a promise of endless possibility. The infinite expanse around us is not a void, but a canvas. It means that the universe is a place of boundless potential, a realm where, given enough time and enough space, anything that can happen will happen. It is a universe where there is always another star, always another galaxy, always another horizon to wonder about. In this feeling, our smallness is not a source of despair, but a source of freedom. We are not the center of the story, with the weight of the cosmos on our shoulders. We are simply a part of it, a single, humble note in an infinite, beautiful song. We are the universe's way of looking back at itself, a momentary flowering of consciousness in an endless garden. There is a profound sense of peace in this. It removes the pressure to have all the answers, to conquer or to own. Our purpose is simply to be, to observe, to wonder, and to appreciate the brief, beautiful moment of awareness we have been given. What this really means is that the infinite can be seen as either a prison of loneliness or a field of endless freedom. It is a reflection of our own inner state. It is the deep philosophical question that the French scientist and philosopher Blaise Pascal wrestled with in the 17th century. He wrote of his terror at the eternal silence of these infinite spaces. He felt the profound unease of a human mind trying to find its place in a newly vast and centerless cosmos. And yet, this same vastness can inspire a sense of spiritual connection, a feeling of being part of something so much larger than ourselves that our personal worries and fears begin to dissolve. It is a universe that asks us to find our own meaning, not in a final destination, but in the journey itself. But what if this isn't the whole story? What if the universe is not a field, but a home? But what if the cosmos is not an infinite open field? What if, as some of our quieter, gentler theories suggest, we are living in a universe that is finite, a cosmos that is closed like a sphere, or folded in on itself like a torus, a universe that is vast but not endless, a single, unified, and ultimately knowable home? What does that possibility feel like? How does it change our sense of place in the grand scheme of things? It is a profound shift in perspective, away from the awe of the boundless and towards the quiet comfort of the intimate. To feel this, let us imagine ourselves not on a ship in an endless sea, but sitting in a vast circular room. The walls are so far away that for all practical purposes, they might as well be a horizon. The ceiling is a perfect dark dome, filled with the familiar soft light of the stars. The air is still and peaceful. At first, this room feels just as infinite as the open ocean, but deep down, you know the truth. You know that if you were to walk in a straight line, in any direction, you would eventually, after a long and winding journey, return to the very spot where you are sitting now. You know that this vast chamber, for all its majestic scale, is a single, closed and complete space. There is a deep and profound sense of peace in this knowledge. The universe is no longer an unknowable, terrifying abyss. It is a home. It may be a mansion of unimaginable size, with billions of rooms, but it has walls, it has a structure. It is a place you could, in theory, come to know in its entirety. It is a place where nothing is ever truly lost, because there is no outside for it to get lost in. The light from every star, every event, will travel around and around this great cosmic room forever, creating an eternal, whispering echo of all that has ever happened. In this finite universe, our significance changes. We are not a lonely speck in an endless void. We are a part of a single coherent system. Every piece of the cosmos is ultimately connected to every other piece. The light from our own galaxy is, at this very moment, on its long journey to the other side of creation, and the light from every other galaxy is on its way to us. We are all in this together, in the most literal sense imaginable. There is a sense of cosmic community, of a shared destiny. It is the feeling a sailor has upon realizing that the entire ocean is just the surface of a single round Earth. The world suddenly feels smaller, more precious, and more deeply interconnected. What this really means is that a finite universe offers a sense of definition. It gives the cosmos a personality, a shape. It is not a random, endless sprawl, but a specific, elegant, and perhaps even beautiful object. The 20th century physicist John Archibald Wheeler was a master of this kind of thinking, a man who saw the universe as a participatory, self-observing system. A finite universe feels like a place that could have a story, a narrative with a beginning, a middle, and perhaps an end. It is a cosmos that feels, in some strange and beautiful way, complete. This feeling of intimacy, of living inside a single great thought, offers a profound comfort. It suggests a universe that, for all its mystery, is ultimately a home. It is a place that holds us, and this brings us to a final, gentle reflection. Why do we even ask this question in the first place? So why do we ask? Why do we lie awake at night and wonder about the end of space? Why has this single, simple question driven so much of our science, our philosophy, and our art? The answer perhaps has less to do with the cosmos itself and more to do with us. The search for a cosmic boundary, for a final, definitive edge, is a deep and profoundly human instinct. We are creatures of beginnings and endings, of shores and horizons. Our lives are measured in chapters, our lands are defined by borders, and our minds seek the comfort of a frame around the picture. To understand this impulse, let us imagine ourselves as ancient cartographers. We are in a quiet, candle-lit room, bent over a large, unfinished map spread across a wooden table. The air smells of ink and old parchment. The center of our map is detailed and familiar. It is our home, our village, the rivers we know, the forests we have walked. But as our gaze moves outwards, towards the edges of the parchment, the details fade away. The familiar coastlines dissolve into speculative squiggles. The lands become emptier, marked with warnings. Here be dragons, terra incognita, the unknown land. Our life's work, our deepest and most passionate desire, is to fill in those blank spaces. We listen to the stories of sailors, we study the paths of the stars, and we dream of one day drawing a clean, solid line around the entire world, of finally knowing its true and complete shape. This is the human condition. We are born into the center of our own small, familiar map, and we spend our lives trying to understand what lies beyond the edges. The search for the end of space is the ultimate expression of this cartographic impulse. We are trying to draw the final, definitive border around reality itself. This desire for an edge is also a search for meaning. A story with no end is just a sequence of events, but a story with a beginning, a middle, and an end can have a purpose, a moral, a narrative arc. We look for a cosmic boundary because we are hoping to find a hint of a cosmic story. We want to know if the universe is a finite tale with a plot we can someday understand, or if it is an endless, rambling monologue. Our search for a physical end is a projection of our search for a philosophical one. What this really means is that the question, what happens at the end of space, is a mirror. It reflects our own anxieties about the unknown, our own desire for security, and our own deep need to feel at home in the universe. We are looking for a wall to lean against in the vast, dark room of existence. The cosmologist George Ellis, a deep and philosophical thinker, has often reflected on this, on how our scientific models are always shaped by our human preconceptions, our aesthetic and metaphysical biases. We are not just passive observers of the cosmos, we are active participants, asking the questions that our human hearts need to ask. There is a quiet beauty in this realization. Our cosmic quest is not just a scientific endeavor, it is a deeply personal one. It is an expression of our own restless, curious, and meaning-seeking nature. We look to the heavens to find the shape of the universe, but in doing so, we also discover the shape of our own minds. And this brings our journey almost full circle, back to a quiet, familiar image of our own small, precious place in the grand cosmic scheme. That quiet, familiar image of home, seen from a great distance, has the power to reframe everything. In the late 20th century, a small robotic spacecraft called Voyager 1, having completed its grand tour of the gas giants, was about to leave our solar system forever. At the request of the astronomer Carl Sagan, it turned its camera around one last time to take a final family portrait of the planets. From a distance of nearly 4 billion miles, the Earth appeared as a single tiny bluish-white pixel, a mote of dust suspended in a sunbeam. Sagan called it the pale blue dot. Let us float there for a moment, in the silence of interplanetary space, and look at that dot with him. It is a lonely speck in the great enveloping cosmic dark. On this single pixel is every human being who has ever lived, every king and every peasant, every saint and every sinner, every creator and destroyer of civilizations, every mother and father, every hopeful child, every explorer and every cartographer, every single one of us, for all our triumphs and our tragedies, has lived out our lives on a mote of dust, suspended in a sunbeam. Now let us gently pull our perspective back, using the knowledge of our long journey tonight. That sunbeam is a tiny flicker in the spiral arm of a vast galaxy, the Milky Way, which contains hundreds of billions of other suns. Our galaxy is just one of many in a small, quiet cluster of galaxies, and this cluster is just one insignificant node in a great web-like supercluster of galaxies, a single thread in the cosmic tapestry. And this entire visible universe, this vast web-like structure that we can see, may be just one tiny, smoothed-out, inflated patch in a much larger, stranger reality. It may be a single flat page in an infinite library of other worlds, each with its own story, its own laws. That pale blue dot is a dot, in a patch, in a bubble, in a sea of possibilities. Seeing our world this way does something profound. It does not diminish us. It unites us. From this vantage point, the borders on our maps, the divisions that seem so important on the ground, simply vanish. The shared vulnerability and the shared preciousness of our tiny world becomes overwhelmingly clear. Sagan saw this with a poet's heart. He saw how this perspective could be a powerful antidote to our own self-importance, a humbling reminder of our responsibility to be kinder to one another and to preserve and cherish the only home we have ever known. What this really means is that our cosmic journey, our search for the end of space, is not an escape from our human concerns, but a path that leads right back to them with a renewed sense of clarity and perspective. The vastness of the cosmos is not a reason for despair, but a reason for wonder and a powerful call for humility. It teaches us that our questions about the universe are ultimately questions about ourselves, about our place in the grand scheme of things. The search for the end of space is not just about finding an answer. It is about learning how to live with the magnificent, beautiful, and humbling scale of the question. It is a journey that brings us not to a wall, but to a state of profound and peaceful awe, and there is a final, quiet beauty in this. And so we find ourselves in a quiet and beautiful place, not a destination, but a state of mind. Our long journey to the end of space has not brought us to a final wall, or a definitive edge. Instead, it has led us to a series of ever-receding, ever more beautiful horizons. We have arrived at the profound and peaceful realization that there may be no simple answer, and in that lack of an answer, we find the truest beauty of all. To feel this, imagine we are a lone mountain climber. For years we have been on a great pilgrimage to climb what we believe is the tallest and final mountain in the world. The journey has been long and arduous. We have spent countless nights under the stars and countless days making our slow, patient way up the rocky slopes. We can feel the cool, thin air in our lungs, the solid, rough texture of the stone beneath our hands, the quiet, steady rhythm of our own heartbeat. Our goal is the summit, the final peak, the very end of the world's climb. And then, one clear, cold morning, we make it. We pull ourselves up over the last ledge and stand, weary and triumphant, on the summit. For a moment, we feel a sense of perfect completion. The view is breathtaking, a panoramic vista of the world spread out below. But then, as the morning mist in the distant valleys begins to clear, we see something that changes everything. Far beyond our peak, stretching out to a new and impossibly distant horizon, is another mountain range, with peaks that are even higher, even more majestic, and even more beautiful than the one on which we stand. In that moment, we feel not disappointment, but a deep, profound, and joyful sense of peace. The journey is not over. The world is so much larger, so much grander than we ever imagined. The purpose was never to conquer the final mountain, but to experience the climb, to witness the view, and to be humbled by the sheer endless beauty of the range. The unknowable horizon is not a failure of our quest. It is the very thing that gives the quest its meaning. This is our relationship with the cosmos. Every answer we find is a new summit that reveals a grander, more mysterious landscape beyond it. The cosmic microwave background was a peak. The theory of inflation was another. The idea of the multiverse is a whole new range of snow-capped mountains, beckoning from a distance we may never be able to cross. The end of space is this beautiful, ever-receding horizon of human curiosity. It is the quiet, cosmic whisper that says, there is always more to wonder about. What this really means is that the universe's greatest gift to us may be its mystery. It is the not knowing that keeps us looking up. It is the open question that fuels our science, our art, and our deepest sense of awe. We are not meant to arrive at a final answer and close the book. We are meant to live our lives on the journey, forever inspired by the beauty of the unknowable. And so, our journey ends where it began, back with that simple question we first asked in the dark. And so, here we are, at the end of our long, quiet journey together. We began in the stillness with a simple question: where does space end? We started by searching for a wall, a solid and familiar boundary at the edge of a great dark room. It was a human question, born of our experience with rooms and shorelines, and we brought it with us to the cosmos, but we found no wall. Instead, we found a horizon, a gentle fog bank on a cosmic ocean, an edge made not of substance but of time. We learned that the very ocean itself was not still, but was a growing, stretching canvas, carrying everything apart on a silent, endless tide. This profound motion forced us to shift our question from where to what. We were no longer searching for a location, but for a shape. We walked on the surface of a sphere, a world that was finite but had no end, a place where a straight line, followed for long enough, would bring you right back home. We explored the possibility of seeing the back of our own heads, of finding our own ghostly reflection in the most ancient light. We looked for evidence of this shape in the faint, ancient glow of the cosmic dawn, and found instead a perfect, impossible flatness. This flatness, a state of sublime and unlikely balance, hinted at a violent, inflationary breath in the universe's first moment, a breath that may have turned our entire cosmos into a single calm prairie in a much larger, wilder landscape. Our search for an end became a search for the edge of our own local neighborhood. We imagined our universe as a looping, mirrored room, where the sky was a tapestry woven from a single, repeating pattern. We journeyed further, into the purely speculative, and saw our cosmos as a single bubble in an eternal, boiling sea of creation, a single book in an infinite library of other worlds. We wondered if it was all just a hologram, a projection on a distant wall, or a tapestry woven from the finest, smallest threads at the very bottom of reality. What this really means is that the question itself has been our guide, and the journey has been the answer. The question was not a destination, it was a path. It was a quiet, luminous thread that led us from the familiar and the solid to the abstract and the wondrous. Each time we thought we had an answer, the universe simply offered us a more beautiful, more profound question in its place. The search for a wall became a meditation on time. The meditation on time became a contemplation of shape. The contemplation of shape became a deep dive into the very fabric of reality and the nature of existence itself. And perhaps that is the final, most peaceful answer of all. The universe doesn't have an edge you can crash into. It has a soft, gentle horizon of wonder that you can drift towards, endlessly. It is a mystery that is not meant to be solved, but to be held. It is a story that is not meant to be finished, but to be lived in. There is no final wall to worry about. There is only the quiet, endless and beautiful mystery of it all, a comforting blanket of possibilities to wrap yourself in. So, let the question dissolve, let the journey fade into the stillness, and let the vast, quiet and peaceful cosmos hold you as you drift off into a deep and restful sleep.